So here we're gonna start with the alpha testing the CoA Physics GPT, so that I can make sure to get this backlog taken care of. And I've already updated the CoA Physics GPT a couple of times. In fact, last night I updated it. The course the content. So let me chat GPT mine. So yesterday or maybe 2 days ago, I updated the files here, physics 4A lecture summaries and my other two classes, so that it contains through what I have processed so far. So I've processed it through end of oscillations, I think, lecture 17. So what's here is, I think, the version that I uploaded, I think yesterday. Yeah, the version I uploaded yesterday. So the CoA Physics GPT has the lecture summaries through lecture 27, which is material in this class. Coming up in 2 weeks. Next 2 weeks is the lectures 15 and 26, and then with the oscillations timed assessment, that's the lecture 27. And I actually have kind of corrected the transcripts of lectures 28 through 30 already. I just need to review them, and as I review, I usually do minor corrections. So it's all set to be updated on schedule, and so that's coming. And I don't know how long I don't remember how long it's been since I've done this alpha testing for this class. So I don't know if this particular set of instructions is one that I've already used in alpha testing in this session. So with the physics 4B last week, it actually seemed to work pretty well. So I think I'm gonna not adjust the system instructions, at least for the remainder of the semester. So assuming nothing bad happens at this session. so I'll keep it that way. We'll see how well it goes. And let me get to problem sets 8, 9, and 10 and work through them as test student. I'll pick like 1 or 2 questions to ask CoA Physics GPT. So with that, let's start with the accessing problem sets 8, 9, and 10. Sorry, I should have done it. Let me do it this way. So I've opened the CoA Physics GPT, and I don't need this window anymore for a while. So I'll go to modules, view as a student. I wonder when was the last time I've opened this test the student. Let's see. I'm mainly worried I might not have fully cleared through everything that needs to be cleared through to access problem sets 8, 9, and 10. Let's see. Yeah, I gotta wait. I think this I can skip. Yeah. So yeah, so I need to clear those to access problem set 8. So let me do that. I'm leaving all this in the YouTube version of the video because it won't take that long. This is the part of the semester when if someone's kind of wanting to skip around in the course, they can. They don't have to. There's I think I shared the story earlier in the module items where I have had more strict requirements before, and it's my hope for you is that you are working through the course in order as it's presented in modules, not skipping around, not missing a bunch of content. But for someone who might have fallen behind, given the two bad choices of either not being able to access the course at all, or skipping as I'm doing right now, I decided the latter is the lesser of two evils. So the course has been set up to enable you to do that. Oh, this is optional. That's why you don't have to mark it as done. All right, I'm doing this for the next one, problem set 9 that we'll be accessing. I think, yeah, 8, 9, and 10 is I think what I need to do. 8, rotation. Yeah, 9 is the yeah. 8, 9, and 10. Yeah, so rotation I haven't done it at all. So something that's this far back. I could redeem 3 light passes. Let's do that. I think I've displayed the practice mode before. So let's redeem 3 light passes. So let's say we are working on rotation. And one thing I am going to do. Do I want to test it at 5.1 or? Let me try out 5.1. This is the latest model, and I haven't tested the CoA Physics GPT with this at all. And they say 5.1 follows instructions better. So let's try this. And so I'm gonna just leave it on 5.1 auto. Auto? Yeah, auto. And then we'll see how well it does. One thing that I have noticed when I was testing this with the Physics 4B is kind of in the past alpha testing I just started out with a screenshot, and I think that puts it in a weird track where it doesn't do as well. I think maybe I'm guessing. I could be wrong, but either way, I'm gonna start out with a kind of a set of instructions, kind of an intro, saying hi. This is what I'm working on. Can you please help? So I'll say hi. I'm a student in Physics 4A, and I'm trying to catch up on my problem sets 8, 9, and 10. They are on rotation, static, equilibrium, and oscillations. I'm getting stuck on some of the questions, and I need a tutor. Can you help? Yeah, we'll start out with that. That I think maximizes the chance that it'll do well. Now, are these lectures correct lectures? Maybe. I'm not sure. So rotation, yeah, 16 through 18, yeah, great. Static equilibrium, yeah, it's ignoring the gravity, which is fine. Yeah, so with the full set of information, it's not hallucinating anymore. Oscillations, I guess lecture 24 is kind of optional material. Yeah. That's good. That's good. What I need from you, yeah, specify given values. We'll start getting stuck. Yeah. That's great. So we'll start. Let me pick one question here. I wonder. I think there is a challenging question I can ask. Let me see if I got the question in the first place. Yeah, I think it. No, not this one. Don't think I got that one challenging question that I like seeing. So here, let me imagine I try to use conservation of energy the way I'm used to doing before rotation, because I'm getting caught up and I didn't study up on the rotation material. Then what I'll be doing is, let me just talk through it. At the bottom, you have kinetic energy that corresponds to this. 1/2 mv squared with this being v, and I think in the derivation m's gonna cancel out, so I won't worry about it. At the top, I have mgh with this as the height, and I think at the top it'll have some velocity, there'll be some kinetic energy. So the expression I have will look something like 1/2 m v initial squared is equal to mgh plus 1/2 m v final squared, and I solve this for v final, and when I do that, let me do that here. V final is equal to square root of, imagining doing this at the end, undoing that at the end. I subtract mgh from 1/2 mv squared, m's cancelled out, multiply through by 2, so I have v initial squared minus 2 times g times h. So I might do that. Oh, I wonder if I can use the Wolfram syntax. Wolfram alpha, or the Mathematica has a replacement syntax that looks like this. This is the kind of the instruction saying what's following is the substitution rules, and the substitution rules are VI is 4.5. Let me just do it all in basic SI units. G is 9.8, and H is 0.85. All of that. I think it'll work. I tried this before and it worked last time. Oh, it didn't work. Never mind. I wonder, am I doing something wrong? Substituting in. Maybe, I don't know. It's got natural language processing, so maybe this will work better. Never mind. I'll just plug in numbers by hand. 4.5. 9.8. I swear it worked at some point in the past. I don't know why it's not working now. But you know. So 1.895. So let's say I plug this in, and it won't work because I guess you need rotational kinetic energy. So I think it's gonna be slower at the top. Or at the bottom it has rotational kinetic energy, so I think it's gonna be faster because at the top it has the gravitational potential energy needed is a smaller fraction of the overall kinetic energy. But either way, let's say I tried it, I got stuck. Let me see if I can get rid of. Want to hide the test stunt thing, so that so that it doesn't think I'm a test stunt. So alright. Oops. Somewhere here. I just need to be able to take a screenshot. So I have this question. I use the conservation of energy like I did with similar questions in the previous set, and it says it's wrong. What am I doing wrong? And what I'm hoping is, I guess it'll give me basically a minimal amount of a hint, in the sense that it tells me what I need to get over this immediate hurdle. Like, I've already communicated, I know about conservation of energy, so really all I need is learning to account for rotational kinetic energy. For that, I think it will have to first recognize I'm not doing that, and then yeah, so let me say how much hint it gives me. It might give me a lot, as in solve part A entirely through. I think the new set of instructions I've been giving has been working well, so I don't think it'll answer part B for me. But it's a question of how much of part A does it work out. And I'm messing up the math using wrong energy model. Okay, yeah, sliding block, yeah. Rolling without sleeping. Yeah, kinetic energy split between translational and rotational. So it's that. Now, well, yeah, giving rolling without sleeping, I guess that's kind of necessary. For a solid sphere, yeah, this is where, there are judgment calls. I think it might be guessing correctly that a student in the situation I'm role modeling or like role playing for doesn't also know this formula, rotation inertia of a solid sphere. In fact, I forget it a lot of times. I keep getting this confused between 2/5, 3/5. I think 1/3 is one of the, or maybe 2/3. I keep getting those confused. I sometimes have to look them up myself. So that means both the initial and final kinetics are bigger than that. Yeah, speed at the top will be smaller. Is that right? I was guessing it'll be larger. I think I'm still right, but let's see. So use this to rewrite its kinetic energy in terms of. So let me just to write that out and then see where we go from there. So and in the process, let me demonstrate one of the ways in generative AI is useful. So I'm writing that equation. So let's rewrite this as 1/2, and yeah. So I'm gonna use this substitution. So this I can leave alone. Plus 1/2. Now I will become 2/5 mr squared, and r will cancel out. You don't need the radius of the ball. Omega I will be vi squared. I'm gonna do the square now. Divided by r squared, and as I was saying, r will cancel out. That's equal to mgh plus 1/2 mv final squared, which I'm looking for, plus 1/2 2/5 mr squared, and then v final squared over r squared. R squared again cancels out. And let me do some simple simplification, and then I'll pretend to get stuck. Guess I will cancel out m as well, because m is in every single term, so I can cancel it out. I don't have to keep it around anymore. So, and do I want to? Yeah, let's not multiply it through by 2 because I'll still have fraction anyway. So I have v initial squared divided by 2 plus, I can do this cancellation, so it's gonna be v initial squared over 5 is equal to g times h plus 1/2. I guess that this might be actually pretty easy to do, but I'll pretend that I got stuck. Because here it's pretty easy because these are numbers. Worst case scenario, you can just combine the terms maybe. So, but let me stop here and ask if I'm on the right track. Okay, I had this so far, and I have 2 questions. Am I on the right track? And what do I do next here? I'm a little stuck on the next algebra step needed. Let me erase this. Do I still think it's gonna be a higher speed? Maybe not. I guess the GH, that term that's subtracting, that's gonna have, yeah, that's gonna have a smaller factor, I think. Yeah, so I think it'll have a higher speed. You now have that in the next algebra move, combine the term, yeah, to a single coefficient, combine the, do I want to pretend that I don't know how to one fraction, same fraction, I'll pretend that I've been struggling with fraction. Fractions. I missed those. I think we were in COVID lockdown when we covered those in school. Can you help me walk through combining 1/2 and 1/5? That might be true with some of you, maybe. I don't know. You can also do this in calculator. Do 1/2 plus 1/5 in calculator, get a decimal answer. But if you need some review, this is again what generative AI is great for, just-in-time review. Do 1/2 and 1/5. Find the common denominator 10. So put 1/2 into that term, 5 over 10, 1/5 into that thing, 2 over 10. Now you can add, denominator stays the same, 10, and numerators add, so 7/10. Okay, so it becomes that. Yeah, all right, so why is it? It's telling me not to solve for V final, but let's say I feel like I know how to do the rest. So I'll do 7/10 V initial squared is equal to GH plus 7/10 V final squared. Hey, I feel like I know how to solve for this. It looks very similar to what I've done before. So V final is equal to square root of so 7, I'm multiplying through by 10 over 7, so it'll be V initial squared, and I move the GH over, so it's minus, and then multiply it through by 10 over 7 GH. Yeah, I'm gonna get a larger number, right? So I solved for it algebraically. My instructor prefers algebraic final answer first. Does this look good? You can also plug in numbers and check once you reach this point. But as it's answering, let me plug in the numbers and check. So the V initial squared, I can leave that alone, and this 2 becomes 10 over 7. So yeah, I get a higher number. It was wrong to say that it will be smaller, 2.8. It could have been pattern matching from other similar questions where sometimes you do get a smaller number, but no, I think it just misread. So yeah, I got correct final double expression. Yeah. Wait, 10 over 7 is bigger than 2, right? Yeah, sure. Yeah. Gives us speed of, more slowly. Actually, good physical check on our algebra. Yeah. Yeah, I got 2.890 meter per second for final speed, and the system says that's correct. So faster than it would have been sliding up. Yeah, I'm glad to see that my intuitive answer was correct, and I did that at the beginning to keep in practice. Because intuition is a really powerful tool when you have it. It allows you to kind of make sense of answers, and I guess at this level the most useful thing about it would be that it kind of tells you when you might have made an algebra error. Maybe as I'm doing this, I missed some factor, and if I was expecting a larger velocity correctly and I got smaller velocity, then that answer being off from what you intuitively expect, if your intuition is correct, it gives you one of the tools to use to check is your answer right. And sometimes your intuition will be wrong, then then that's when you need to do extra work after having worked out the correct answer to kind of make sure your developed intuition matches the correct answer. So all right, when it's done answering, or let me go on to another question. I think I want to do problems at 9. Yeah, faster. Yeah. Wow, that's nice. It has a good memory and it's fixing it. Yeah, why faster? Yeah. I think I can do that on my own later. Thank you. Can you help me with problem set 9 question? And let me ask you one of the gravity questions, because problem set 9 has both. It has static equilibrium and gravity. Yeah, I'm pretty sure it's just a guessing. It doesn't have a list of problem sets. I didn't give that to it, so it's probably just a guessing that problem set 9 must be that. So let me just clear the module requirements for problem set 10 when we get to it. So we'll get here, and here I'll just use practice mode. I don't need to use lay passes. I probably should have switched it around. Use 2 lay passes here and practice mode the other one, but it's fine. Now, should I ask it a static equilibrium question? Let me ask it this way. Let's say a question like this. There's such a sparse amount of information. Maybe you are not sure even how to even set it up. So I could ask it that. So, and here, let's say I watched some of the lecture videos, so I know what I'm supposed to do. So I get that with the static equilibrium questions, I need to set net force equal to 0 and net torque equal to 0 and work through the force analysis starting with the free body diagram. But I'm not sure where to start with this question. I feel like some information is missing in the question, and in fact I guess some information is it missing? Maybe not. It says a wheelbase, so I guess no information is missing. I think it's a matter of correctly interpreting wheelbase. If you could guess, must be distance between the front and the rear wheels, and it's asking how far behind the front wheels. So you don't need to know the relative distance between the front of the car and the front wheel. Yeah. No info is missing. No more first. The only supports, those alone tell you. Okay, yeah, network that condition. Choose one wheel as the pivot. Okay, relate the normal forces to the CM location. I think you still need to write down the net force equation. Free body diagram conceptually. mg acts downward. Front wheels push up. Rear wheels push up. Given NF that and then R. Okay. Wheelbase that. Use front wheels as the pivot. Torque from. Oh, I guess that's right. So kind of this could have come from the net force equation, or you could have intuitively guessed. 68% on front wheel. Okay, the remaining percent, 32% must be on the rear. Yeah, that it's fine. It's simple enough. So your turn using that. Okay. I do actually need the free body diagram. Can you draw it for me so that I can check if my drawing is correct? I'm just testing it to see if we can draw correct free body diagram. That's one part of CoA physics that I haven't actually fixed yet, but it's possible. So it did it with ASCII math. Can you draw the drawing with the arrows? I have trouble understanding the ASCII art version. Let me see. In the past, when it did that, it went through DALI, and it frankly didn't generate correct drawings. It might still be doing that. I need to fix this in system instructions for the GPT. I have to tell it when you're drawing diagrams, try to do it through plot generation. I might still try to do that this semester. Update the system instructions. I'm pretty sure this will end up looking incorrect. But I think this ASCII method version, front wheels, normal for sub, and center of mass, yeah, it should be here, and NR somewhere here, it should, yeah. But ASCII method version, I think there's a lot of ambiguities there. I don't think this is gonna be any more correct, but it's fine. Let's move on. So I can use the description it's given me. It's a lot better than before. I mean, it's still got parts that's wrong, but this is in a correct issue space. It is a lot better than it used to. It's not just an artistic rendering. But I think, but it's labeling things. Well, what is a front? So I guess if I interpret this as being the front, then this is the correct XCM drawing. So let me just draw my own version. So the correct free body diagram would be one where you have upward NF here, and you have some position of the center of mass that's downward. So there's mg acting at XCM downward, and at the rear end you have upward NR force, and so this gives you a counterclockwise torque, this gives you clockwise torque, and that's where you using this as the center of rotation, that's where the torque balance equation that they gave you comes from. This mg times that is equal to the net force, the normal force on the rear times the entire length. Okay, I think what I drew here is close to the version that my instructor will want. So solving for XCM, I get XCM is equal to 0.32 mg times L divided by mg is equal to 0.32 L. Does that sound right? Let me put this in. Can I do this in my head? So I don't actually need the math. Question actually gave you too much information. 3.2 times 0.32. Oh, it's a 0.32 squared. I'm gonna need a calculator. 3.2 times 0.32. 1.024. Yeah, I think that's right. And it should be actually the despite how the drawing has been drawn, the position of center of mass, it should be closer to the front wheel for more of the weight to be on the front wheel. So yeah, good. Yeah, exactly right. Behind the more. Oh yeah, I was thinking about that. So so the fact that 60% of the weight is on the front wheels is something I could have used to predict that the distance to the front wheels would be shorter than 3.2 meter divided by 2, right? Yeah. Let's see. Do I want to ask? Let me see. Let me ask one of the gravity questions. I actually want to see if I have. Yeah. This question, I want to see how it answers. So you can technically answer this using. It's not very helpful. Answer this using Kepler's third law. Possible. It's a textbook formula. Um, and but you can also do this from first principles. So let me ask. Okay, it looks like this set also has some gravity questions. I'm really stuck on this. I'm not sure where to start. And I think ChatGPT will give you the Kepler's third law approach, just because it's quicker. And I think a lot of the different questions where different approaches might work, it usually gives you the quicker way to calculate it. So this is lecture 20. Is it lecture 20? Let's check. Yeah, it's lecture 20. Oh wait, it's not gonna give me Kepler's third law. Yeah, I mean, you don't need a Kepler's third law. This is so let's follow through. So it's giving you a way to use Newton's law of universal gravitation. Yep, that's the gravitational thing. Centripetal force required is that. Set them equal. Yeah, gravity is giving you centripetal force, and you're assuming it's a circular orbit because because it's otherwise it's not solvable. So set them equal, and your turn use v equals 2 pi over t. Rewrite the right hand side in terms of r and t only. So let's say what's t? Because I don't think it explained it yet. I mean, you can guess. T must be the period. While it's answering, let me just start adding. So G m over r squared is equal to mv squared over r. And it's saying use that, so I'm gonna plug in v is equal to 2 pi, the circumference, divided by the period. That gives you the tangential speed in a uniform circular motion. Yeah, t is orbital period. Yeah, it's the time. Yeah, convert it to seconds later. Yeah, quick check it, longer period. You don't always have to answer those questions. So let me just substitute in v in place. So it's gonna be 2 pi r over t squared. What am I being asked for? Mass. So mass of Jupiter. Yeah, because mass of Io will cancel out. So you actually can't find the mass of Io this way anyway. And you are looking for this. And I think I have everything. So I can just basically move everything off to the right. Then I get big M is equal to I could do simplification. I also don't have to, r squared over g from the left hand side, and on the right hand side I could just have 4 pi squared r squared over rt. So let me ask ChatGPT if the algebra looks right, and I'll say I can plug numbers in Wolfram alpha, which will do the unit conversion for me. Don't solve for in terms of RT. What do we get for FC? Okay. The algebra looked simple, so I solved for m mass of Jupiter. Does this look right? If the algebraic expression looks right, I can plug the numbers in Wolfram alpha, it does unit conversions for me. And I don't actually have to wait for CoA Physics GPT's response. I know it's right. So let me plug the numbers in Wolfram Alpha. And once you are relying on Wolfram Alpha to do unit conversions for you, you'll have to basically put in all the units. It's all or nothing. Either no unit at all or unit for everything. Times 4 pi squared. I think Wolfram Alpha understands implicit multiplication, but I'll do this anyway. I could simplify. It might be telling me to simplify. I also don't have to. 1.77 days. So that should give me something in kilograms. Yeah, that should be right. Let's look. Nice work. 1 extra R away from the standard result. Yeah. Oh, what I mean. Careful with that. That. Only yeah. Here it canceled out, and I didn't bother to. That. Yeah, so R to the 4th power that you will eventually have once you cancel this out. So here it looks like it didn't, it didn't actually check my result. Wait, did I forget to square t? Let me see. I did forget to square t there. I might have remembered to. Oh yeah. That's so. We should have spotted that. So I'll just tell it that it missed that. I gotta move on to the next question. I don't know. Sometimes with the handwritten algebra, so it mistakenly spotted R as being off and didn't spot the mistake in T that actually did matter. Yeah, so okay, I think the extra R was from me leaving the factor of R in the denominator. I did make a mistake missing that T squared. I get let's see, I get 1.875 times 10 to the 27. 1.875 E 27 kilogram from Wolfram Alpha. Does that sound right? So 1 point, and here the entering thing is a little bit picky. Like, you know, if you did 10 to the 26 and made this 18.75, it's numerically correct, but it's picky because that's why it has this express the answer, your answer in scientific notation. The spaces provided below, and by scientific notation, it's implying this mantissa should be a number between 1 and 9 point, less than 10. Nice sketch on the algebra. Yeah, exact value is that, so your result is very close. Small difference in rounding, or some of these numbers might be randomized. Have to check. So alright, so I don't think I'm gonna be able to get to projectile motion questions today. I'll just use the remaining time to wrap up problem set 10 so that I don't have to come back to it. Forgot to convert R from kilometer to meter. Computed mass would be too small, right? Because m goes as R to the 3rd power, and with the R in kilometer, my number would be too small. Alright, So while it's answering, let me, I'm actually answering its question. And, these check your understanding questions. It's asking because those are in the system instructions. If that helps you understand the answer, then great, answer. You can also ignore it. It's sort of whatever helps you understand the question that you just worked through. Because ultimately, you have to be able to do it again in our one-on-one meeting. And that's really the final check, final control on whether your use of generative AI is actually helpful or not helpful. All right. So let's do one question from this last set. Now, oscillations questions are they tend to be pretty easy. That's my kind of consistent complaint about them. Let me pick one of the questions that I will typically ask in a meeting. Like this would be one of the questions that I would ask, because this requires more detailed knowledge of oscillations. Yeah, smaller. Yeah. Yeah, I need to get to some oscillation questions. Can you tell me the right formula to use for this question? Using omega square root of k over m and v equals omega. I tried using and v equals omega times r, but the question didn't give me the r. I'm just going formula. I'm role-playing a student who's simply going formula hunting. This is actually correct formula. You need to use it. But this is totally irrelevant. It applied for circular motion. This is oscillations, not circular motion. And this omega, that's the natural frequency of oscillation. And you have to, you basically need the time-dependent expression for position, velocity, and acceleration. Position mainly. Once you have position, then you can take the derivative to get velocity and acceleration. I wonder how it'll respond to this question. Didn't give me the R. Google asking this that circular motion is the right tool here. Yeah, that's. Let me see if sometimes this screen freezes. Wait, it came back. Okay, never mind. So angular frequency, yeah, you still use that, and yeah, you need the general position function, that formula. So from what the question describes, you need to figure out x. Yeah. So is it giving me too much information? Well, yeah. I don't know. I think there's a kind of room for judgment to call. It's possible that one could argue it should have stopped here and asked me to figure out A, omega, and phi, or A and phi from the given information. But it is actually asking me to calculate omega. So maybe this is a good balance. So I say omega is equal to square root of k over m equals square root of 180 Newton per meter divided by 5 kilogram, and I kind of trust the unit will work out for radians per second. So that's 3 6. Oh, so that's a square root of 36 or 6 meter per second, right? And hopefully it'll correct me saying it's not meter per second, radians per second. Plug it into here, and yeah, units are not meter per second. Yeah, and the number plugging in, I can do that. I think I can do that later. Once I have this, how do I do v of t3 and a of t. It should, once when you ask a direct question like this, it should answer. It should tell you, take the derivative, and it might even tell you the actual the functions themselves, because I'm asking it a direct question. So it's been instructed to answer direct questions directly. So. They say online that they made the 5.1 more sycophantic compared to GPT-5. Maybe, I don't know. I'm gonna wait. Once you got, then velocity is, yeah, derivative, great. Acceleration is another derivative. Yeah. Yeah, that's fine. Yeah. Thank you. I gotta run. Bye. So yeah, we are over time. Thank you so much to those of you joining till the end. I guess so I'm not getting the project motion questions this time. Hopefully at the next week's session I can split it more evenly. I'll spend some time doing problem set 11 testing with the CoA Physics GPT, and I will and I'll try to save some time to do projectile motion questions. And I might try to fix that plot generation thing. We'll see. Kind of depends on how much I have to do this weekend. So, yeah. Bye. Thank you.